All right, this is the lesson video for section 11.2, special right triangles type 1, okay? So we're dealing with right triangles. Let's just a little bit of a review on what is in a right triangle. For a right triangle, has to have a right angle, okay? Right here, two of the sides make up the right angle, and you have one side that is across from the right angle. The side that is across is called the hypotenuse, and it is the longest side of the right triangle. The other two sides that make up the right angle are called the legs. So we're going to be using that terminology today in the video. So problem number one, what we're doing with this problem, we're just kind of exploring kind of the relationship between these types of triangles right here. These are all the same type of triangle, and what we'll do is we will formulate a relationship between the legs and the hypotenuse of these type of triangles. Okay. So find the hypotenuse x for each right triangle below using the Pythagorean theorem. Leave your answer in simplified square root form. Okay. So we've got the Pythagorean theorem. Remember, says c squared equals a squared plus b squared. C represents the hypotenuse, or the longest side. A and b represent the legs of the right triangle. Okay. That's what we're going to be using for these problems. I'm going to only do A, C, and D because I think that's enough for us to answer some of the questions below. So my hypotenuse is x. We don't know it, so it goes for C in the Pythagorean theorem. So it's x squared here. Then the rest are going to be, the legs are both 7. Okay, so this is 7 squared plus 7 squared. All right, 7 squared plus 7 squared in my calculator gives me 98, because it's 49 plus 49. So x squared equals 98. We remember, to get rid of an x squared in an equation, you take the square root of both sides of this. Okay, so x is equal to the square root of 98. Now 98 is 49 times 2, obviously, because we're 49 plus 49. So now when I simplify the square root, the square root of 49 is 7, because 7 squared equals 49. Remember, when that happens, let's write it like this: 49 times the square root of 2. Okay, this now becomes just 7, and then you cannot simplify the square root of 2, so x is equal to the square root of 2. 7 square roots of 2. All right, for C, very similar. X squared equals 3 squared plus 3 squared, which is 9 plus 9. So x squared equals 18. So then x is going to be equal to the square root of 18, which we can simplify. 18 can be written as 9 times 2. The square root of 9 is 3. So x is 3 square roots of 2. You might be able to see the pattern so far about what the hypotenuse of this type of triangle might look like. But let's do one more to guarantee it. Okay. So this one, x squared equals 14 squared plus 14 squared. Okay, 14 squared, I believe, is 196. Yes, it is. So 196, and then plus 196 is 392. Take the square root of that. Square root of 392 can be written as 196 times 2. The square root of 196 is 14, like we just saw. So this will be 14 times the square root of 2. Alright, so let's use these three, what we just did, to answer P2, okay? So P2 part A says, what do the lengths of the hypotenuses have in common? Notice that all of them have this square root of 2 in there whenever you simplify it, okay? So they all have square root of 2. Okay, also, if you look at that, well, look at what's in front of the square root of 2. You have a 7, a 3, and a 14, okay? Now, looking at our triangle, now the 7 is the side length of this triangle, so that's kind of interesting. Oh, it's the same for this one as well. For C, 3 is the side length, and then for D, up here, 14 is the side length, and it also is in our answer as well. So I'm going to hypothesize that this is going to be the side or the leg times the square root of 2. Okay, that's what it looks like. All right, besides being right triangles, what other types of triangles could you classify these as? So let's look at one triangle. Right off the bat, I notice that both legs are 7. They're the same. What does that mean? And this one, let's check it. They're both 3, and this one's both 14. A triangle that has both sides the same length these are called isosceles. All right, so an isosceles, these we can call these right isosceles triangles. Okay, so you'll hear them mentioned like that as well. All the triangles have the same angle measures. Find the measure of the three angles. Obviously, we know one is 90. That means the other two angles add up to 90, because not 180 minus 90 is equal to 90. All right, but since it's isosceles, we know that the other two angles have to be the same measure, because that's the property of isosceles triangles, so that two angles are the same. So if they add up to 90, to find what they are, you can just take 90 divided by 2 and find that they are 45 degrees. All right, this leads us to this down here. It says, using your answers to the questions above, we can state a formula for the side lengths of these special right triangles. We're going to call them 45, 90 triangles based on what their angle measures are. So in a right isosceles triangle, or also known as a 45, 90 triangle, oh, that's wrong, isosceles, with legs of length L, remember they're both the same, the length of the hypotenuse will always be the length of the leg multiplied by the square root of 2. And we saw that up here, okay, right? This leg was length 3, multiplied by that square root of 2, and we get 3 square roots of 2. So for a little formula, if I have the leg and we call it length L, the hypotenuse would be L times the square root of 2. You have to remember this. This is how we're going to solve all of our problems today, okay? So remember this relationship, L square root of 2. So it says this is a relationship between the leg and hypotenuse, and it provides an alternative to using Pythagorean theorem when we know the triangle has angle measures 45, and 90 degrees. This also means that we only need one side length to be known to find the rest of the lengths for these triangles. Okay, so let's answer some questions. In problem number 3, we are given that one of the legs is of length 8, and we want to find the other leg x, and then we want to find the hypotenuse y. This is a 90 degree triangle because it has a 45 in here. The other one has to be 45. So we know in these types of triangles the legs are equal. So x is also a leg, and we know the other leg is 8. So x is also equal to 8. Okay, now to find the hypotenuse y, we remember up here we talked about it being the length of the leg times the square root of 2. So y will simply be y equals 8 square root of 2, and we're done. That's all you have to do. Some of these are going to be very simple to work out. Some are a little more involved, but that's okay. Now this one, find x and y. Again, you're given a leg of 25. It is a 45, 90 triangle. The other leg y will also be 25, so and then to find the hypotenuse, you just take the leg length of 25 and multiply by the square root of 2. And we're done. Now for P5, what if we're given a hypotenuse to begin with, not a leg? Okay, so let's talk about, in these two right here, we started with a leg and multiplied by the square root of 2, but when you're going to get the hypotenuse, right? But when you're going backwards, instead of multiplying by the square root of 2, you will divide by the square root of 2, okay? Because division is the opposite of multiplication. So x and y will be the same as well. So 19, we're going to take that and divide by the square root of 2. But if we remember from our simplifying radicals lesson, we can't keep a square root in the denominator, so we have to rationalize it by multiplying the top and bottom by the denominator, by the square root in there. So up the top, these just become 19 square roots of 2. And then this is going to be any square root multiplied by the same square root. All you have to do is drop the square root and take what's inside. So we have 19 square roots of 2 over 2. Okay, and that would be x, and it's also going to be equal to y. All right, number 6. Find A and B if the acute angles of the triangle are 45. That means these two angles right here are 45. This is a right isosceles triangle, or 45, 45, 90 triangle now. Now, A and B are our legs. So if I have A is going to be, you take your hypotenuse, 8 square roots of 2, divide by the square root of 2. Now, I could rationalize this, but I also noticed that they both have square root of 2 on top and bottom, meaning that they can cancel each other out, and all we're left with is 8. So B is also equal to 8 then. 7. This one here, we're given a leg to be 9 square roots of 15. The other leg is A. It's 45, 45, 90 triangle. So A is also 9 square roots of 15. To get B, we take this 9 square root of 15 and we multiply by the square root of 2. Okay, when you're multiplying a square root, okay, you can multiply, excuse me, you can multiply the two numbers that are under square roots. So we'll multiply the 15 and the 2. The 9, however, will stay by itself out there, and we'll get 19 square root of 30. 30 has no perfect square factors in it, so that's as far as we can go with that. So that'll be our answer for our hypotenuse. 8. The length of each leg of an isosceles right triangle is 5. Okay, cool. I have a 45, 45, 90 triangle with leg length 5. So write it out. I got 5 and 5. To get our hypotenuse, remember we just take the leg and multiply by the square root of 2. So this will be 5 square root of 2. Now, it wants us to find the perimeter of the triangle. Okay, perimeter is just adding all 3 up. So, excuse me. So add 2 5s and then a 5 square root of 2. So when you're adding things with a square root inside them, right, it's kind of like combining like terms, right? You can only combine things with the same square root in them, right? So this is not going to be able to be combined with anything, so it'll be by itself. But we can combine the 2 5s to get 10 plus 5 square root of 2. This is the simplest form for an exact answer right now. However, it doesn't really tell us that much. Like, it's hard to visualize a length of 10 plus 5 square roots of 2. However, what we can do is we can put that in my calculator, and it will give us the decimal for us, okay? Because I don't expect you to, I don't know what that is as a decimal just by looking at it. So typing in 10 plus 5 square root 2, I get, let's put that into decimal. I need a better calculator, I guess. Well, this one doesn't work. Alright. 10 plus 5 square root 2, it's about 17.071, and this is in, oh, we don't have any inches or anything, so this is just what it is, 17.071. Okay. So, find the perimeter of a square in exact form, not a decimal, if the length of its diagonal is 14. Alright, so we have a square. Notice that whenever you have a square, we know that all sides in a square are the same. So they're all x. Alright, so then we know the diagonal is 14. Alright, I have a right isosceles triangle here, meaning it's a 45, 45, 90 triangle. Okay, so we can solve for x by doing by knowing it's 45, 45, 90 by just taking 14 and dividing by the square root of 2. Rationalizing that, we've got 14 square root of 2 over 2 now, and 14 divided by 2 now becomes 7. This is the square root of 2. Alright, so to get the perimeter though, we add that up 4 times, or multiply by 4. So the perimeter is 4 times 7 square root of 2. You can only multiply the 4 and the 7, so the perimeter is 28 square root of 2. 10. Find the length of the diagonal of a square if its area is 18. Okay, so square. Let me draw it out. Excuse me. The area is 18. If we call the legs, the sides x. Okay, the area of a square in terms of it's just side squared, because they're all side times side, which is side squared. So in this case, it would be x squared. Now we know the area, so why don't I just write 18 for area? Now, I have an equation, don't I? I could just solve for x by taking the square root of both sides. Simplifying this, this can be written as 9 times 2. So the square root of 9 is 3, so x is 3 square root of 2. And then to find the diagonal now, you multiply this by the square root of 2. So, call this d is equal to 3 square root of 2 times the square root of 2. Remember when you multiply the same square root twice, it gets rid of the square root, so then we have 3 times 2, which is 6, I guess, millimeters would be my unit. And that's the lesson, guys. Let me know if you have any questions. I know I moved kind of quickly, but if you need me to further explain something, let me know. All right, have a good day.